I built two wireless game controllers. One is 3D printable, under $25. The other is a completely over-the-top $600 version. CNC Aluminium, transparent resin, visible electronics and LED lighting. But both had to work on everything from a modern PC to a 40-year-old Amiga. And I might have forgotten to design a space for a power switch before ordering $600 worth of parts. This video is sponsored by PCBWay, more on that later. Let's start with the reasonable version, because it will also serve as the prototype for the more elaborate one. Before ordering the expensive parts, I had to make sure everything would fit and function properly. The main case of the joystick is made up of two halves. The bottom half is designed to house the batteries and all the micro switches. The stick is attached to the upper half with a spring-loaded mechanism. This keeps it centered and returns it to the neutral position. I'm using a small microcontroller for the logic. I wanted it visible through the clear resin case, so I designed a space for it in the upper half. I printed the parts with as little support as possible. The bottom half prints fine as is. The upper half is trickier, so I printed it at a 45-degree angle. This lets me use less support, and it also makes the curves look smoother. Because the top half prints at an angle, the fit is not perfect. So I made a soft TPU gasket that squishes slightly when the case is closed, hiding small imperfections between the parts. As you can see, I went through quite a few iterations before everything functioned and fit as intended. Getting the springs to the correct tension took a few attempts. Placing the micro switches just right was not easy either. I ended up printing this part of the case with a hole in the bottom. That way I could see exactly why it was not lining up. But with everything tweaked, there is now very little play between the components. I was confident I could make the electronics work and went to order all the high-end parts. I uploaded my files to PCBWay, and for the case I chose a resin material with a spray varnish, which makes it more transparent. The stick and buttons will be CNC machined from aluminium with a blue anodized color. You request a quote and they check whether the parts can actually be made. If anything needs changing, they send you a picture with some information to help you adjust the design. I now had about 3 weeks to solve the real challenge. How do you make one wireless joystick work on both modern computers and 40-year-old hardware? I wired up the microswitches and could then send their state wirelessly using ESP-NOW through an ESP32-C3 microcontroller. On the receiver side, I used an ESP32-S3. It is similar to the C3, but this one can also support USB HID, which I need to get this working on modern computers. I won't go through the code, but I'll put it on Patreon along with schematics and printable files. I want to get this working on my old Amiga and Commodore 64 as well. But before that, I need to confirm that it actually works. This is a game controller, so if there's any noticeable lag, the whole project is pointless. For the first proper test, I used an Amiga emulator and one of my favorite games, Extreme Racing. And this is honestly working way better than I could have hoped for. The controls feel immediate with no noticeable lag. It simply feels like a proper joystick. But now I need to get rid of this wire sticking out of my supposed to be wireless joystick. So the next step is to make it battery powered. I was a little bit hasty when I designed it with just 2 AAA batteries. At this point I started questioning whether this would even be enough. There was only one way to find out, so I wired the batteries through a small boost converter and connected it to the ESP32. Up until this point, I had only been powering it from USB. And that's when I realized I had never actually designed a space for a power switch. The solution is to make it power down after a few minutes of inactivity. To save even more power, it only sends each update a few times before backing off. The premium version's LED lights also use a little bit more energy. If builds like this are your thing, please consider subscribing. While the parts were being manufactured, I turned my focus to the receiver. To make it work with retro hardware, we first need to understand the joystick port. Each direction and button is just a simple switch connected to its own pin. To show that, I connected a single microswitch between pin 6 and ground. When I click the switch, a connection is made and the car accelerates. But instead of using a full set of physical switches, I can use a microcontroller to simulate those button presses with the help of a few basic components. I made a simple frame for the electronics, then wired and soldered everything together. The frame and microcontroller was mounted in the enclosure and the final wires were soldered onto the plug. Both receivers are ready and now we can finally have a look at the parts from PCBWay that just arrived. I've been really excited to see how this turned out, so let's unwrap them and take a closer look. The aluminium parts are pretty much flawless, and the blue color turned out very nicely. And thankfully the case is actually as transparent as I had hoped. The CNC and resin parts are made with fairly tight tolerances. But the surface finish also adds a little bit to the overall thickness. Thankfully, I left just enough clearance and it slides in without any issues. Next, I installed the springs and the small clip that holds the stick in place. The buttons actually rest on top of the microswitches, so there is very little margin for error. But it can be adjusted by making a slightly taller or thinner gasket. I made a small frame for the LED filament bars, and it will also be used to hold the ESP32 in place. I ran some of the wires through the frame to keep everything a little tidier. With the ground wires in place, I soldered the signal wires as well. There is quite a lot of wiring in this version because of the extra LED bars. My over-the-top Dream version is finally assembled. But now we need to give it a proper test and compare it with the sensible version. First off, let's try it on some real retro hardware. This machine is now around 40 years old, but it still powers on, so let's plug in this dongle and see if it actually works. I tested it with a couple of games, and just like the emulation test earlier, there was really no noticeable lag. In terms of battery life, the sensible version lasts about 2 hours on 2 AAA batteries. And around 90 minutes for the Dream version, all down to the extra LEDs. The feel of the two joysticks is actually pretty similar. But because of the smooth surface on the aluminium stick, the premium version feels slightly smoother. On the 3D printed version, you can feel a little bit of friction because of the layer lines. The extra weight of the aluminium part also makes the Dream version feel a little bit more solid. Holding both buttons for 10 seconds puts the joystick into deep sleep to save battery. And if there is no input for 3 minutes, it goes into deep sleep as well. To wake it up, just push any button or move the stick. I also have a Commodore 64, so I plugged in the dongle and fired up a couple of games to test it in there as well. In this game, it is quite important to have a quick response from the controller, but it performed really well. For me, I think both controllers look really nice, but I would love to hear which one you like more. One day I'll get myself a desktop CNC machine to make parts like this myself, but matching this kind of finish and color at home is not easy. But it would be fun to try. So was it worth spending $600 on this, or am I crazy? Let me know in the comments. Thanks for watching.